Hello, everyone. We're live right now. We're going to do the Fry It and Find Out Lab. We have Sean Calderon here with me. And guys, we're going to have a fun time. We're going to set up in cold voltage first, and we're going to go through. As you see in front of me, I got some pretty cool stuff to go through. We have mineral oil. I have cooking oil. I have this stuff here for sunburns. I have some lard. I have some honey. We got some ice. And just because it's the holidays, we got some pumpkin pie. How you doing, Sean?
Hey, doing great, Nathan. Thanks for having me on the live stream. So those of you in the chat, I probably will be reminding you throughout the presentation, but I will be monitoring your questions or comments. So feel free to interact with Nathan there in the comments, and I'll do my best to let you interact with Nathan real time.
Right on. Okay. So I got this black light as well. Okay. And I am going to attempt to use my cell phone every once in a while on this tripod to see if I can't get some closer shots. So give me a second to hook this up. All right.
Stefang says, get the lidocaine ready.
Hey, you guys take some bets, man. See what you guys think. Do you think these things will even allow it to light up in the oils? Because we know we put with AC flybacks, we put the mineral oil in there, and that'll actually stop the sparking over. So I'm curious to see. Then we have the vegetable oil here, okay? And sometimes they use vegetable oils instead of the mineral oil. So let's see if it works. So with that said, I'm going to move this stuff to the side so you guys can start seeing stuff. So Sean, I asked everybody the other day what they wanted to see.
Yes.
And mineral oil and oil was on there, and they wanted to see honey.
Oh, interesting.
So we're going to start off right here with our mineral oil. Man, I feel like an oil salesman right here. Look at me with my nice shiny mineral
oil. So just to be clear, this is going to be the ZVS Tesla coil first?
Yes, we're running the ZVS Tesla coil. We're running it on DC with the rod down the center. We're doing it in cold electricity, so it's just going to see if it lights it up. This has been something we've been doing for a while. If you're new to this, it'll be interesting. So don't ever get discouraged in case it doesn't do it right away. But with that said, let's run this and just verify that the light will come on. Give me 1 second.
Can you give everybody an idea of the input voltage and output voltage?
Absolutely. Okay. I turned everything on to go live right now. And where is this? Oh, my little probe thing fell down. I'll have to put that back up. Okay, so right now we're just going to go. Right now it's at 12 volts. And we turn it on.
Nice.
We can see the black light lights up pretty good.
Very cool. It's one wire, right?
What's that?
It's only one wire, right? There's nothing at the other end?
Well, here it is. That's it.
Nice. Look at that.
Check it out. It's tripped. See how the light's going right there to my fingers?
Yeah. Can you hear the high-pitched squeal on your end?
I can't hear nothing.
As you move your hands, it makes a whirling whistle sound. Yeah, do that. It's like slide it up and down. It sounds like an instrument.
That does right there?
That sounds like a UFO hovering over your garage.
Oh, man. I feel so wrong holding it like that. All right, Sean, now that you embarrassed me.
Oh, boy.
Okay, first test, Sean.
Yes.
All right, so we know that the circuit works, okay? Here we go. It's just sitting there in the oil, both sides of it. Power's on and we're resonating and we got our no-go. No joy, no light, nothing. This is the mineral oil.
Interesting.
So it does not conduct through mineral oil. All right.
If you put the electrodes super close but still having an oil gap, does it jump across that?
So we'll turn it back on. We are 1 inch from it. I got nothing. We are 1 millimeter from it. I got nothing.
Wow. It's an insulator.
Yeah.
Interesting.
So I guess they're right when they say put your AC flyback into mineral oil.
Yes. To cool it down.
All right. I'm going to move these out. And clean these things off. And the next one we're going to go to is right here, the vegetable oil. Man, this stuff is thick too and nasty. It gets all over the place.
Eighth Sinner has a comment. UFOs usually sound much more low-pitched, like a hum. At least the ones I've seen flying past a drone close enough to capture it. Interesting.
Oh, nice. That's awesome. Okay, real quick. All right. Now, same test, but this time the vegetable oil. Yeah, I should have done this one last. I got that oil on my hand.
Oh, no. Oil gets everywhere.
Okay, now we're firmly in the oil now. All right, here we go. Again, we're 14.5 volts right here. And I'm resonating. I got no joy.
Looks like it's an insulator again.
Okay, so we're going to go at 13 volts. I'm going to put it next to it. No, we're a millimeter away. I got nothing. It absolutely kills it.
Yeah, looks like it.
So we'll just, I guess Joe was right. It's not going to go through any oil.
Yeah.
That's okay. It's not going to stop my fun today. I got some fun planned today.
Nathan.
Yes.
If you run the one wire into the oil, could you put a fluorescent bulb in the oil like you used to do, putting it in the sand or putting it in the water?
Well, if there's no conductivity through it, there's no point in putting it in there. It won't work. There's no energy being passed through the oil.
But I'm wondering, you're right, no current's going through, but I'm wondering if it doesn't electrify the outside, just the surface, which means that it's still insulator under it, but maybe it has an outward. Does that make sense?
So do you think it would light up the glass? Is that kind of where you're going, or?
Right.
I'll give it a shot.
Yeah. If you bring the light to the glass of oil,
I think the glass will light up, but I don't know that the other one will. So let me grab a big tube light, turn around and circle over here. I don't want to get this other one all gunked up right now. I don't have another one next to me.
Okay.
So we're resonating right now. It's over the wire. It lights up.
Right.
And we have it at a distance.
Interesting.
No joy. But then up here at the top, well, it was lit. Now it's out. We're getting nothing through it, Sean. There's no light up.
So oil really is a good insulator against high voltage. And
yeah, as soon as I get it out of the oil, though, look, it turns on.
That's funny.
Well, hold on. But it's the outside of the glass itself that's doing it.
Oh, I see.
Yeah, lighting up because of the glass. You can tell
Interesting.
by when you put it at the distance right there, it kind of tells all tales, huh?
Yeah. And it just running that tall fluorescent bulb over the work area, it kind of gives you an idea of how strong the field is there, that you're working in a really big electrified field,
Oh yeah.
and yet you're directing the one wire energy through oil, and that's when it's extinguished.
So when you see those big things over there on your poles going in between the houses, that's probably why they put mineral oil in them. So
That makes sense.
yeah, I'm gonna try to move this, Sean. This thing is like a machine of just gunk now.
Oh no.
Should have done this last. Like it literally is all over your hands. It's like
It's part of the fun to watch you get all lubed up.
oh, you're bad as Joe now.
I know.
It's all good.
Junior high bathroom humor. Sorry.
John's getting acclimated, man. We're good. All right. So this is Ocean's Potion. The burn stuff. Yeah. So let's try this out. Now I got these two little wires there so I can goop. I should have done that on those over there. That's what I get for prepping so slow.
You're doing great.
That's not long enough. Let me just grab another wire here. Yeah, I got to clean out my garage and get rid of a bunch of stuff so that this is easier to set up. All right. We are firmly in the goop.
And this is for sunburn. Is that what it is?
Yeah, sunburn stuff. So when you get done being cooked in the sun, you put this on to feel better. It's like aloe. It says aloe vera and lidocaine. Let's see. Tea tree extract. I don't know why they have that in there, but hey, if it works, it works.
Interesting.
There we go.
Ooh.
Aha! Oh, I like the blue goo.
Wow.
Which I guess shouldn't surprise us because it has aloe vera in there, which would have a water content.
Right.
So I was saying yesterday when I did a video that I think it's the water content itself that's doing this for us. You know what I mean?
Yeah, it makes sense.
Okay, so let's do your other light bulb.
Oh, interesting. There we go.
Yeah, it lights up real good, huh?
That's so much energy for 12 volts input.
It's more than most people's Tesla coils get, and I'm getting it out of blue goo.
Yeah. Oh, yeah. That's crazy. The blue.
Oh, yeah. Oh, look at that.
Wow. That's cool.
It likes that.
That's amazing.
I like cleaning it. Oh, man. Gross.
Just real quick, guys, we're seeing you come on in the chat. If you want to put your questions or comments in the chat, I'm facilitating this part of the presentation. So Nathan wants to make this more interactive. So please let me know, and I will relay your comments and requests to Nathan as he's doing his experiments.
All right, Sean, what do you want next? Do you want honey or do you want lard?
Well, you have a request for honey by Ulysses. So.
All right. Oh, man. Okay. Wow. Okay. Oh, that's why. Good thing I brought a knife.
So while you're working on the honey, Eighth Sinner says tea tree, or some words I cannot pronounce, stimulants cell growth, and it's highly antiviral, antibacterial, and antifungal. So it would stop any infections taking hold, whilst the aloe keeps it very hydrated. Good to know.
Well, let's talk about the honey, because this is nasty, man. Let me tell you, I like the way honey tastes, but this is like some goop.
It's crystallized. Have you run it in the microwave for 10 seconds? It'll liquefy.
Well, if I had a microwave, we'd be blowing up hot dogs in it. All right, hold on. Make sure it's off. Oh, God, everything.
From mineral oil to honey. You need those latex gloves so you can just take them off all the time.
Oh, yeah. I got big sausage fingers, so it's never fun to put on latex gloves.
So,
okay.
Stang has a comment. If you have some silica gel.
Some what gel?
Silica.
No, I don't.
Mr. Lanius, aka Vortex,
Jarvis,
aka Super Electric Man. I'd like to see table salt mixed with mineral oil.
That'd be interesting.
Yeah,
I might have to take a break when we're all done and set that up or do a separate test. All right, guys, let's check it out. We got the honey, we got the electrodes hooked up, we got our light bulb ready to go.
Oh, wow.
Is it lit up a little?
Yeah, it is. On this camera side, it's lit over to the right.
There we go. We give it some more power. We're at 22 volts now. Now you can see it, right? So ultimately, honey is a poor conductor.
It's very interesting.
Still, okay, hold on. Yeah, see, it's not really a whole lot of light there.
What's interesting is honey can be left out and it won't mold or anything, but it conducts, which means there might be some water content, and that doesn't make sense. It shouldn't have water in it. So something else is conducting.
You never know, Sean. I don't know what it is.
It's fascinating.
That's why we test everything. You know what I mean? That way people in their labs will know, hey, this is what it does. How about, you think ice will do it?
Wow.
So I got ice here. I already have the electrodes in it.
Let's see it.
What's your guess on it, Sean? What's everybody think?
So Ulysses, what's that?
Got any yeses or nos?
Anybody want to see electricity go through ice? Put it in the chat. Ulysses says, let's get sticky.
I'm already there.
He's already there. Mr. Lania says, lighter fluid.
Oh, I won't do explosives. I won't try that. I do not have the garage for that. I will be the explosive if I tried.
There's a question about the honey real quick. Did the honey melt when you were running electricity through it?
No.
So
not at all.
Okay. So let's see here. Yeah, you're getting yeses for the ice.
All right. Let's hit this thing up.
Yes. Awesome.
We're going 13 volts, Sean.
Sounds good.
I got no joy. Let's go a little higher. 23 volts. I still got nothing.
It's very interesting.
Oh, hold on. It's there. It's there.
Yeah.
See it?
Capacitor, I think.
It's got a little bit.
Yeah, it does. But if you let go, it doesn't. Oh, no. It's hard to tell.
Yeah, got a little bit. I'm at 25 volts right now.
Mm-hmm.
And I got a little bit in there. It doesn't like to be ice cold, I guess.
It's Is it melting? Because I know the melted water could be a conductor.
Well, yeah. I have no melting in here, Sean.
Oh, wow.
Nothing. It's still stuck in the ice. No, I'm wrong. I'm wrong. We got a little melting. It's moving a little. Maybe that's why the electricity picked up in it, huh?
Yeah, I think so. It would.
Well, I don't want to melt it too bad because I want to run some hot voltage through it. But man,
Yeah.
it's starting to go now. Okay, maybe chain reaction. All right, I'm gonna put that aside real quick because I want to try one more thing. Let me see. Do I have anything over here? Let's see. Because I
So
want to show you.
Light seen as a comment.
Go ahead.
It's good for storing energy. Not sure what that means. Maybe he'll give some more in the chat.
You know what? Hold on. We're gonna have some fun here. All right,
So,
first, go for it, Sean.
Sorry about that. Lance is asking you, Nathan, are you trying your MOSFET Slayer exciter for your Tesla coil?
On this stuff right here, my Slayer exciter will do this all day. I don't have it set up, but I can do it. So, Sean knows my Slayer exciter. That's what I used outside, by the way, to light up the pond.
Yeah.
I didn't use my ZVS. I used my Slayer exciter.
And it makes sense because the Slayer exciter has a feedback loop. So when it's always attaining resonant frequency, regardless of what you connect it to. Where the ZVS won't do that. It doesn't have the feedback. So it makes total sense.
Okay. What do you got on the pie? Here we go, pumpkin pie.
So you put a wire on each end and then get your plastic fork, and take a bite.
Yeah. Here,
So Papa Bale says H2O is not a good conductor. It needs salt. That's true. That's true.
The energy I use is a great conductor, though, usually. Hold on. Here we go. Are you ready?
Yes, let's see it.
Just place it into the pie. Oh, look at that. Look at that.
Oh, wow.
Oh, I went up the other one.
That's a powerful pumpkin pie.
Oh, look at that. You like some pie?
How does it taste?
Oh, that tastes good. If I didn't have my denture in, I'd be eating it right now.
So Anthony Williams says thin wood.
Look.
In radio electronics, they had it glow from the inside before turning into splinters.
Huh.
So thin piece
you
of
see
wood.
this, Sean? Check this out.
It's so bright.
I'm just plugging it in I'm poking my pie. Huh.
It's weird how the pie it's just interesting. I mean, I guess there's moisture in the pie, right?
There's a water content, yeah. So what else we got here? Oh, you didn't get to see this one yet the other day, Sean.
Okay.
This is frozen burrito.
Nice.
All right, you guys think it'll conduct through the burrito?
Is it frozen or is it?
It's a little mushy. About the consistency of the pie, probably.
Ulysses says yummy. Stefan says at least it's not a dry pie. Oh yeah, I've eaten too many of those.
Oh yeah.
Stephen Drysdale says he can hear it. I'm wondering if there's sometimes there's just some frequencies that are coming off when you're moving things.
Oh, there is. There's sound coming off. My mic picks it up.
Yeah, it's very faint.
What do you think? We good? There you go.
Look at that. Plasma burrito.
Oh man, that's so great. Hold on. Let's just
Happy
have a little
New
more
Year
fun.
to all.
I'm gonna hook this to this light over here because it's already on, right? What do you think?
Yeah.
It'll get brighter when I hook it into the burrito?
Oh my god!
I got a burn out of it. Oh,
be careful. How many? What's that? 13 volts in?
Yeah. There's so much power in that burrito.
It's a
oh my
burrito.
That's insane. Look at how bright that is. Look, watch.
That's crazy, and it burns you.
And it burned me through the burrito.
Do you think it's the beans? The lent some? I mean, what is that?
I don't know. That's so hilarious. Dude, I love it when food lights stuff up and people get tripped out.
I did not expect the burrito at all. 8 Sinners asking what frequency is the coil running at?
431 kilohertz. It goes up and down 1 or 2 kilohertz. It fluctuates just a little bit. So we know it goes through there. Let's go back to the honey real quick, because since we got so much going through this one.
Is it warming the burrito? Does it feel warm? Oh, as you're squishing the burrito, it's making strange noises. It sounds like you're killing a rat.
You ever had RF burn? I'm getting that off of the burrito. That burrito is awesome.
That's amazing.
Okay, we're in the honey now. On one side. I'm going to clip the light now. No, not a ton brighter, but it did get brighter. So from burrito to honey to the light, we got more energy.
Wow, that's fascinating.
It's making the honey a little better conductor than it was.
Yeah. That doesn't make sense.
Seriously, that burrito give you RF burns, man. I don't know what's going on there. That's it. 13 volts, man. We don't have a lot of voltage in there. Whatever's in that burrito, like, now I'm afraid to eat those things. Like, what did they do to the burrito?
Yeah. Maybe it's the preservatives. Maybe there's some sort of metallic preservative. I don't know.
But I ate the burrito yesterday after I did the test. Now I wonder if I should.
So a lot of comments on burrito. Resisto burrito.
It's not hot at all now. There's no, the RF's gone. My aluminum acted just like the burrito. Huh.
You should use the burrito as an instrument, like your multimeter, your burrito meter.
My burrito meter. Nice. Oh, that's crazy. All right, burrito's going to the side. We're using you later. All right, what do we got here? So we had RF. So what do you say? We got some big grapes here.
Wow.
All right, let's, where did I have that dish? I get them as close as I can to each other. I want to see if any plasma forms.
So warp mode says the Casimir effect proves that there is 0 point energy.
That's true. And when you do the Casimir effect, you usually take some aluminum or take anything you want, the metal. If you use aluminum, you'll have an accidental laser on your hands, but you put them close, and what it does is it forces your dielectric to the inside. So normally Steinman says you're magnetic, dielectric. Well, in the Casimir effect, you're taking your dielectric out here and pushing it to the inside where your magnetic's out here. That's why it defeats Lenz's law. That's why the Casimir effect will create cold energy, the negative voltage. It's the same thing in the Tesla hairpin circuit when he did it. It's the same thing with the rod down my Tesla coil. It's the impingement of it that forces it in.
That's fascinating. Eighth Sinner says, so microwave frequencies run about 30 to 60 gigahertz. I think that's a bit high.
Yeah.
Digits, which we know has a wavelength that explodes grapes. Your 431 kilohertz, so not gigahertz, but kilohertz, the wavelength might be too long to turn it into plasma unless there's some harmonic in there. That's an interesting point.
So we're saying no. Hey, it's worth a try.
Yeah.
So we're on, we're resonating. Lights on.
The grapes are singing.
Are they?
Yeah, it's a high pitch squeal. It sounds like a dentist drill, a root canal.
Oh, wow. You know, I did these kind of tests with my cell phone and it doesn't pick it up.
Oh, the sound's gone now.
No, I turned it off.
Oh, I see.
So, okay.
Mike Faraday says you need a pineapple.
Oh, gotcha. These things smell like aluminum.
Oh, wow.
Let me put the...
Elijah Tech says it's cold plasma. Anthony Williams, microwave usually runs about 2.4 gigahertz. Yeah, that sounds more correct. A few at 900 megahertz for commercial models. Makes sense, Anthony.
Okay, I have these things extremely close. Sean?
Yes.
I got burnt marks coming on these things. So hold on. I saw a little spark.
Okay.
Hang on. I'm going to try to use my camera here.
Yeah. Happy New Year, everyone. It's great to see you all in the chat.
Okay. Let's try to get in close to this thing. Can you see it? I can't see. Okay.
Okay.
Go ahead and put it on the big screen, Sean.
Gotcha.
I'm going to turn it on. Let's see if we get a spark. No?
Are you going to slightly move the grapes away so we can see a spark? Oh, wow. Yeah, you're seeing it arcing. That's incredible. That is so crazy. That's some RF yummy. And the camera angle and everything's great.
That's so cool.
It's making a whirly sound.
Oh, it's smelling horrifyingly bad. Oh.
I've never smelled a burnt grape before.
Oh, wow, Sean. That was at 23 volts.
That's incredible.
So, it smells like burnt wood. Oh,
wow.
Worse. Oh.
Super interesting.
Well, the camera works. That's good.
Yeah, works great. Let me throw you back on.
Yeah. Oh, man. That was exciting, actually. That was awesome.
That was totally awesome.
Huh, I didn't know grapes would do that. I thought it'd be the hot voltage that would do it.
Yeah, I didn't expect that at all. It's hard enough to get if you have two, let's say, steel ball bearings, it's hard to get a spark between the two, but to have two fruit little ball bearings out of fruit, that doesn't make sense.
Not a lot of this energy makes sense because we haven't mapped it out yet.
Right. Makes sense. So got some comments here. Stefan G, I'll say it that way. Trying borax solution would be interesting. Borax is an ionic salt. Eighth Sinner says, I think it will conduct, but not plasma and not blow up. Yeah, we didn't see it blow up.
Nope. But we did get some voltage out of it. That was cool.
Yeah, that was way cool. Anthony Williams said he could hear the squeals. Mr. Lanius says, what about sugar water?
Sugar water conducts. I didn't have it out here to use it, but I know it conducts.
Yeah, I think you're right. Lissy says the pitch changes on different items. That's true. Magneto Frico says use a Sony camera with HAD diode. Not sure what that is. Someone is in the comment, light seen within, when I was saying it sounded like a dentist drill, and he said, oh my OMG. More Happy New Year's. Awesome. Great to see you guys.
Right on. I'm looking for a wire real quick. I had it earlier.
Hey guys, if you're enjoying the show, the live stream, please like.
Yes. While the old man was over here blowing stuff up. I'm going to see if I can't run my Tesla coil and AC later and really get some stuff frying here. All right. Now, since we know it lights up, okay.
Much love to you, Stephen Drysdale. I appreciate that. So Mike at Faraday Energy Research and Development says, grapes have capacitance value, so therefore it's like a capacitor. And when it discharges, it comes out as hot electricity. That's why it's burning.
Nice. Okay. Well,
makes sense.
Yeah. Let's give this a shot. Now, this is true old man build style, just throwing stuff together.
This is a plasma cooking show.
So I put it all the way into the rind here. And I just want to see if it sparks any.
Thank you, Chris Hayes, for your membership. Appreciate that.
We got it, members? Right on, man. Woohoo!
Yeah, go Chris Hayes.
All right, so kind of want to lean this up. Let me see. Do I have another grape? Let's just play grape fun. Stacking grapes like a Legos.
Dennis Matovich asks, does any part of the coil heat up under the plasma load?
Yes. It'll push back to the ZVS if you get it too hot.
Ah.
So remember, I tell you, it switches between cold and hot voltage based on your distance. So this is 2.5 inches is the pipe right here for my Tesla coil. So I'm right on the edge of cold voltage. If I use my 4-inch Tesla coil and I put it down, it wouldn't even make any difference.
Ah, interesting.
Okay, you ready to give it a try? Put it on the other camera now.
Awesome, let's do it. Oops. Here we go.
You see my little setup there? Let's now.
It looks like
know.
No light.
Oh, it's.
Oh wow! It was just drilling into the orange. You're gonna get zapped.
Oh, hold on. I have it on? No, I have it off. Okay. Hold on. We'll set it up again. That was
Yeah.
really cool. Sorry. I need to adjust the angle first. Okay. All right, we good?
We're good. We see it.
Oh, we're on. We got nothing. Man, we must have had it in the perfect spot.
Oh yeah.
Nope.
Man. Is it stabbed into the orange or is it just barely touching?
It's not touching. Maybe that's the problem. Hold on. Let me turn it off. I'm going to put it right back in that hole and see if we can't drill some more. Okay.
They got some squealing now.
Oh, it did a little bit and fell.
Yep. It
Oh,
dragged across some plasma.
my rig setup is not so good. That's so cool that it turns it back into hot plasma like that. Right through the orange.
So
Can't
not
leave well enough alone.
Not sure says you're fruit welding.
Yeah, it's not going off. Now it's just conducting.
It's like you got to play with the orange a little bit, like wiggle it.
All right. Maybe it needs to be on the outside. I don't know. Maybe it needed the skin. There we go. We're on it now. Oh, there it went. The skin, just a tiny bit.
You can hear the squeals.
Hang on.
Oh, it's that high pitch, that
Sorry. I can't hear it. Oh, I got a little tiny one. No. Just flip the screen on me.
When you think about what you're doing, it's so funny.
So hold on. All right, so we have it off. Let's go for it. Just shoved it in there. Okay. Sorry, it may be. I just shoved the line in there. Here, I'll show you. Now let's see what we get. You ready?
Sounds good.
All right, 23.4 volts.
Oh, that's a lot. Something's gonna smoke.
Oh, whatever it is, we're not seeing it.
Wow. I thought there'd be some smoke.
Man, hey, switch to the other view real quick.
Got it.
Look how much that light's bright.
Oh wow, yeah.
And it lit up the other one.
And it's just going right through the orange.
Look how high it goes.
Oh wow.
John, I'm almost touching my ceiling. There you go. One side is now touching my ceiling.
And just for some context, the other items that you've tested, it wouldn't go past a couple feet. What you just did is more like 5 feet, 4 or 5 feet, right?
Yeah, so give me a second. Let me check it.
Oh, wow, that's strange.
Well, we also upped the voltage. Remember that. So we were at like 13 volts. We're now at 23. So we got 10 more volts in there, which means we went from 2 amps to 4 amps.
Oh, okay.
So that might be something in there too, but that's so cool, man. This camera works great, by the way.
It does. It's really nice close up.
All right. So we like the pie. I just got to try things. I'm sorry. Okay, hold on. I don't know if any of this is going to work. How do you want to do this, Sean? You want a burrito? You want a grape? I want to try to take and hook up this ring here.
Mm-hmm.
So I'm going to come off of the orange. It just sounds funny. Okay.
And put the grape inside the ring.
Put the what inside the ring?
You just put the grape in the ring?
Yeah, and I'm going to try to take this big 4-foot light and shove it right into the grape. And see if it lights
Oh,
up
wow.
brighter. Okay?
Sounds good.
So we're all on. Okay, switch back to the other camera, Sean.
Sounds good.
Here's our little lonely grape. So we light up. Oh, it did. Look at that.
Wow.
Not a lot, but it's getting more.
Yeah. That grape is radiating.
So hold on.
It's become a capacitor or
Oh,
something.
look at that orange. Watch.
Oh, it's so loud. When you touch it, it's a low frequency. When you release it off the orange, it's a high frequency.
Oh, man. That makes the experiments even better. You kind of have to control your TV, but, man, that's so cool.
It is cool. The frequency, the sparks, it's quite a spectacle.
Okay, so this thing is starting to melt on me, Sean.
What's melting?
My ice. I might have to put it back in the cooler.
Oh.
Well, hey, might as well while it's here, right? Let's
Is it
see.
melting faster?
About the same rate. It's getting a little warm in my room, but that might just be me. So hold on. So I'm going to hook the other side of the ice to the light over here. And we got it running through our orange. It just sounds funny. It's running through our orange through all this stuff, right? Hey.
Yeah.
Why not just see if it works, and then we'll throw another grape in there or something. So here's our setup. We just have it to the ice now from our orange. Over to our ice to that side. Now from the ice over here to the light bulb.
Hey,
All right.
just a bunch of comments are coming in, Nathan, about maybe it's the citrus acid that's giving these extra effects.
Yeah, it might. Look at that.
Wow.
Now the ice is conducting well. And I'm sure because of the stuff's heating up over here because of the orange, the grapes and the oranges. Look how much that lights up.
Anything smoking?
Nope. Hey, look right at it. Look how close I can get the camera to it, though.
Yeah.
No, you can't get your camera that close to your testicle while you're playing.
Right. Exactly. Something's unique about this radiant energy. To get your camera that close and not have all kinds of strange things happen to it. Because the field is so strong, you place that 4-foot long fluorescent tube over any of those parts and it lights up brightly. So that gives you a sense of how powerful the field is around these. For you to have the phone so close, that field is just acting in a way that we wouldn't expect. Okay. Maybe you guys have ideas in the chat about that.
All right. So now we can't leave well enough alone on this channel, Sean. So we have orange power that's going to go over here to our pi power, to our pi 10.
Pi power.
Okay, so we're going to go the water to the pi. Okay. And then we're going to go straight to the pi 10.
Oh, wow. That's to mix metal with the fruit. That's interesting.
Okay. Now we got it set up. So see if we can't follow the connection. We go right here from our orange, and that's going into the pi 10. But then we got it connected to the pi, which goes over here to the ice. Which then It's like a mini golf course, man, but we're doing voltage. And it goes to this light. Okay. If that light over there turns on, man, that's amazing. Okay, hold on. Let me pull a little back. Oh.
That's funny. Oh my goodness.
Oh. Watch this.
What is the pie? Oh, I don't know what to say. You've electrified a piece of pumpkin pie.
And to think the wife was going to throw it out this morning. I go, no. I got an idea. We're going to do it with pie, and I'm going to light voltage out of pie.
Oh my! What was the look on her face?
Oh, just like normal. Like, oh my God, I think my husband lost his mind. Okay. So hold on. I'm going to turn it back on. Now I'm going to stick the light bulb into the pie. I unhooked the one side of the water.
There's a request to cut the orange. Oh, wow. You hear it, Nathan?
I told you I can't hear anything.
That is, so when you touch the pie, it has this deep whirling sound. When you remove it from the pie, it has a high pitch sound. Yes. High octave, low octave, high octave, low octave. Oh, wow. Another different frequency. That sounds like a whirly bird.
Oh, man. Oh. Only me, huh? Oh, we didn't get to the good part, John.
Oh, no.
There we go. We got some
hot dogs.
Big jumbo franks. We're doing advertisements for hot dogs now. Yeah, if you want to see your hot dogs blown up on my channel, by all means, give me a sponsorship.
You'll bring the electricity. They'll bring the hot dogs.
That's right. Oh, get my arthritis all running with this hot stuff. Look at this. Okay. Hot dog power. What do you want to do? We'll hook it up to this light here. I'm going to try to run this way. We'll see what it's like this way first. All right, you ready? Now, from our orange to our hot dog to our light, you know, it just sounds ridiculous.
It does. Stefan said the pie was screaming out.
Look how bright that light is. Oh my.
It's like bright.
That is like one of the brightest times I've ever seen this thing. Look how bright this one is.
It's hot dog power.
Dude, that hot dog got some funky dog in it. It's wow. Okay.
It's also squealing really loud.
It is?
Uh-huh.
Yeah, maybe the hot dog is injured. All right, hold on. We're going to put the light right into the dog.
Stefan Drysdale says the smell of raw pumpkin is an aphrodisiac for men.
Oh, I don't know about that.
Yeah, I was going to say.
Look at that. Look at that. Do you hear anything different, Sean?
Oh, my goodness. Super high pitch when it's off and a deep.
Oh, hold on. Wow. Now I heard that.
That was me whistling. I'm trying to let you know what it sounds like.
Oh, wow. That was taking out my ears.
That was the exact frequency.
Look how ridiculous this is. Look, that's what we're plugged into. We're plugged into a couple of grapes and an orange.
Mr. Lania says it's a whiny wiener. That's
awesome.
My. That's awesome.
Dude, this is outrageous. Okay.
Let's play the whiny wiener again.
Hold on. We got a pack of hot dogs, so let's do this. Okay, let me move some stuff out of my way.
There's a comment. This is the weirdest holiday party ever.
Oh yeah, it is. You know, I know it just sounds like fun, guys, but please understand, I'm showing you what this energy does.
Yeah.
It's not normal. You're not doing this normally. Okay, there's gonna be a lot of people trying to repeat this,
Yeah.
and it's not gonna happen unless you know what I know.
It's simple as hard. You make it look simple, but there's a lot going on. And you could do this all day and not have the exact knowledge. You won't do it. You won't get this reaction. It's a lot more difficult than people would think. It's difficult to get a Tesla coil working well like this, let alone
And we're using it all day to do funky
roast
stuff.
greenies with it. Anthony Williams says, if someone stuck a wire in you, you'd be whiny too.
Yeah. Okay, now look at this. We got some Frankenstein works. Oh, my camera's not working that well now.
Frankfurtenstein.
So look, here we go. One hot dog to the second hot dog to the third hot dog to the light while it's going through the orange and the grapes.
Wow. Let's see it. Oh my goodness.
It's bright as day over here.
It's so crazy. It looks brighter the more hot dogs you added. Oh my goodness. What is going on? That's
man, lost his mind. Okay, I can't resist, Sean. Okay, hold on. I can't resist. We have to add the burrito. No, gonna do it.
Yes, we have. Mr. Lania says, don't pee over an electrified fence.
Okay, I'm gonna pull my camera out and pull it back in to see if I can't clean up the picture real quick, Sean.
Oh, you want me to zoom out?
Oh, hold on.
Okay.
I popped out. I'm gonna pop back in.
Happy New Year's to you, Stefan, in Ireland. Thank you. Another Stefan says, dogs in series.
Okay. There we go. Now try it. Let's see if it cleaned up the picture.
It's not in the middle. You want me to put it back?
Yeah, put it back in the middle.
Why is it acting up? One more try.
No, that's the other one. There we go.
Sorry about that.
All right, now we got a live picture. All right, that's good. So there's the orange to the hot dog, to the other hot dog, the other hot dog, over here to the burrito, to the light.
That is so funny. That is, there's a comment asks, what are the electrolyte concentrations in these? I've never heard of electrolytes in a burrito or a hot dog. I mean, that's interesting, I guess. Oh, and Mr. Lanius asks, it might be preservatives, sodium nitrate.
Yeah, he's right. It might be.
Very interesting.
So let's do this, Sean. All right. I'm going to change this up just a little bit. Now I want to see when I connect it to the other side of the light, it comes out to the other light. Hold on. But I want to go through my burrito.
Hey guys, just to let you know, as you join the chat, if you have questions or comments to share with Nathan, he's glad to take them. So I'll be scouring these comments, them. And Happy New Year.
Yeah, Happy New Year. Thank you for spending it with us. Look at this. Okay. So we got oranges and grapes. Our hot dog set up again. Now it goes through the light, into the burrito, into the other light.
That's so funny.
Okay. Let's see what it does.
Beam power.
Oh, we're on and resonating. I have no light.
What?
Wow. And we're not only resonating, we're resonating good. Oh, I know why. Hold on. This one lost contact with its wiener.
Wiener power.
There we go. Oh, look how bright that is.
Oh, and the hot dogs are whining.
Look at that. That's so cool looking. Man, it's pulling the load through it. Look at that. The burrito makes it go too.
That burrito always has so much energy. It's so weird.
Oh my. What'd you do today, honey? Well, I lit up some hot dogs, some oranges, and some burritos. Oh wow. This is too much fun. Like, nobody would believe this if you just told them this. Like, hey, this crazy guy on YouTube started lighting up his hot dogs.
It's I don't even know how I'd word it. It had to do with electricity and hot dogs. So my goodness. Hey, thanks, John Gray. Just some love in the chat here. Hey, miss you too, Jarvis. Stefan is asking, have you tried it on Gatorade?
Yes, I did it yesterday. The Gatorade works, but it loves pineapple juice.
Oh, interesting.
So maybe Jarvis was right about the acidity.
Yeah, the citric acid. Dennis Matovich says, can you try an insulator?
Like, what am I looking for? Like a piece of
plastic.
It'll kill the energy. It has to be something that it'll push through. An insulator, it won't. Not like that.
Okay, makes sense. Oh, there's a comment here. That's a winner wiener.
Winner wiener.
Winner with a wiener. Oh, that's even worse.
Okay, hold on. I got something for you, Sean. All right. You say it's hard to light up one Tesla coil, right?
You're right. What
are the chances? How do we want to do this? I'm going to use wiener and burrito power. What are the chances I can get a second Tesla coil to light up? What do you think the odds on that is?
The coil 2?
I'm going straight for the number 1 on another coil. Okay.
Elijah Tack says, my girlfriend had a dream she told me about this morning, lighting bulbs with potatoes.
Dude, I did it with a potato. Potato works really well. Okay, check this out. So I'm through all the wieners and stuff like we did last time, through the burrito now. Now we're hooked up to the number 1 coil on that Tesla coil. That number 2 should not light. That should not work, right?
Yeah.
Okay. And there it is.
My goodness. And there's no power to that other than the 1 wire.
Other than the 1 wire. And look, it's going for a distance out from it.
Look at that. It's running hot dogs and burritos.
And it's resonating the number 1 coil to get the number 2 to activate.
Wow.
Some people can't even turn on a Tesla coil, and I got burritos and wieners powering mine.
Wiener power. Anthony Williams says it needs to be on a shirt. Wiener power.
Wiener power with a little face and stuff.
Wiener and burrito power. Yeah. That's awesome.
Oh, man. That's just, that's the coolest thing, man. It's like, it's going through everything, Sean.
It is.
There was only it just didn't like the mineral oil or the other oil.
Yeah, the oils were insulators. They didn't allow the energy to go through it. And so, but all these other food items. Oh, someone mentioned, can you cut the orange in half and just so they can look inside while the wires are going through them?
Absolutely. Give me a minute. I want to test one thing first, if you don't mind.
Sure.
I want people to see this. So this, I'm just going to connect this. I'm going to move all the wieners aside. Okay, sorry, wieners and burrito. I'm clearing you out. Now,
Too good.
I'm going to take this magnet. Here's the wire. Let's see if I can't get the shot. We know the magnet works, right? Okay, now I'm going to turn on this power and see if it's magnetic inside of here. Because I'm sure somebody wants to know that, right?
Yeah.
So you see the light already turned on.
You can hear the squealing.
There is absolutely no magnetic pull. It's straight up and down. There's no magnetic value on the outside.
But there's
Look,
inside.
there's no pushing it. The only sway is because my big fat butt's swaying. So we can set it next to it. The other side of this thing wants to hook up. It has no reaction. The spark. That's it. There is no magnetic value in it. None.
So the field is just contained inside the coil?
Well, it's like I told you, it defeats Lenz's law. So let me turn this off and talk about it for a second.
Yeah.
When I told you cold energy defeats Lenz's law, now you can see why, right? So let's swing it over top. That's got to generate a field, right? Nothing.
Interesting.
This can go all day like this as fast as you want. And because the energy is to the inside, it defeats Lenz's law.
So is that a magnet, a ring magnet?
No, it's just.
Or is that a washer?
It's a magnet I used on my gravity flyer one time. It's a neodymium 52.
And so, of course, it's not going to stick to copper, but when you run electricity through it, then the copper becomes a magnet. Is that what you're showing?
So if it was a magnet, if it was traditional electricity, right?
Right.
I should have a magnetic field right around this whole thing, which you think, okay, when a normal Tesla coil, I put in DC power, which pulses. So I'm pulsing a DC power inside of this coil, right?
Yeah.
So then it would have a magnetic field in it. It would be pulsing magnetic field, right?
Correct.
Now with this one wire energy, it doesn't have a pulsing magnetic field.
Okay.
So, but it still transfers energy efficiently.
And how is that exhibited when you put the magnet on the outside and then the inside?
I should have push on that magnet. I should have a magnet that pulses. So on a normal field, it should go like this.
I see.
I get none of that. So when you get none of that, it's telling you that the magnetic field is not where you think it is. You know what I mean?
Yeah, it's not where you expect it.
So we essentially defeat Lenz's law here when we do this. So it's very important to know that when you go to set this up. So when Gerald tells you, I can turn on mine and the energy comes out, there's absolutely no magnetic field, but I can pull 400 volts out of it easy. Well, now you kind of understand why.
Yeah. There's a comment here from John Curley. The magnetism is alternating back and forth at a high frequency and can't attract the magnet as it's both pushing and pulling the magnet.
You know, I'll take any kind of case that you believe it is. I just know that it has no effect.
Yeah. Someone commented sprinkling some iron fillings around it. That would kind of show how the fields are different with the one wire power.
Okay, that's fair.
Filing, sorry, not fillings.
No, I know what you're saying.
Somebody says that the print toner containers contain iron powder. You can hear the another comment. You can hear the magnet swinging. I know you can't hear the whirling sound, but you definitely hear that magnet making noise.
That's cool. I didn't know that.
Yeah. Another says that it could be from capacitance. Let's see. There's something weird going on that maybe it's a scalar field, which still has a magnetic properties, but isn't organized like a regular magnetic field.
Oh, now here we go. Now we got someone who finally gets it. It is a scalar field.
Good catch, Eighth Center.
This is absolutely what it looks like to play with a scalar field. So what I was trying to tell people in the other video I made this morning is we have to treat this scalar field as a voltage multiplier. So the capacitance is the amount of energy inside the winding. Then we need to add a second winding, but this time with a diode, so that we can get it to go one way and build the field each diode we put in. So we can double the voltage, like a voltage doubler is probably more what it's like. So that's one of the things I'm working on right now with the winding. So I found a winding that would act as the diode in one direction. So now, I mean, it's not perfect by any means, but it's a start. But my goal is to amplify this field as I go up. So the amount of energy I put in to what it is now, I want to make it 5 times that.
So are you saying you're going to use diodes in conjunction with capacitors to double it?
Nope. I am simply going to use the capacitance in each field and wind a diode out of wire, then wind it back into the coil. You see, because these things are pure energy fields, so they work differently. Go ahead and switch the camera, Sean.
Yeah.
So we're not dealing with a normal capacitance setup. Some of this energy doesn't even go into certain capacitors. It won't work. So we now have to rethink how we're doing it. We know that the energy is coming straight out of it. Okay. And we know that that's the magnetic field coming out, not the dielectric field like normal. Now we have to look at it and go, okay, now if we interrupt it and cross it, now what are we doing? Now we're creating a stop when the field is out and making it pinch. Once we pinch it, we can make it go flowing in one direction without it being able to come back. So it's going to pick up energy each time it goes up.
Oh, wow.
And the other side of it, we'll use 2 wires on this, and I'll connect another side of it straight to each one of them. So it fills it normally. This one is the additive that builds up. So I think
the diode in that setup?
The diode is the winding.
The diode is the winding.
Yes.
Have you had a video on how to wind these diodes?
Yes. I haven't made it yet. I'm going to. I just learned it the other day, and it was in a chance YouTube finding. Somebody was winding something, and they were
Mm.
creating more energy out of it. And I don't think that they understood what they did.
Wow.
So,
Sounds
and it's a
exciting.
pretty well-known over Unity setup too.
Wow.
So I know what it is because I look at this stuff all day. So
Yeah.
so I'll come out with it. We'll see how well it works, and
Yeah.
we'll get it going because this right here is a game changer. This is what Ian was looking for.
I
So
can't wait to see it.
there's a couple different ways. If I just wanted over Unity, guys, this
Mhm.
isn't difficult. This is Don Smith, right? This is winding an extra winding on my Tesla coil. So if I wanted more energy out of this, I would wind the winding really close to it, then
Mhm.
have the same amount right here and the same amount right here, but at the same frequency as this big one. So
Mhm.
I would most likely use something like this, right? But
Mhm.
you'd get it really tight and you put plastic in between it. Now, once you get your capacitance correct, you can multiply that energy anytime you want because it's coming out and it's hitting these fields, but they're resonating together. So how do I explain this? If I wanted to take this Tesla coil and turn it on here and have one light up 20 feet that way,
Mhm.
what do I have to do? All I have to do is put them in the exact same resonance frequency and have them both connected to the ground. And it will light up from 20 feet away.
Wow, it's amazing.
That's the power of resonance when you're in the correct resonance.
Right.
So,
And when you're resonating vibrations and electricity, and when you start to mix all of these forces of frequencies, um, the power output just grows exponentially.
that's
It's
right.
power upon power.
It makes a huge difference, doesn't it, Sean?
Yeah, it does. Tesla
So,
magnetic diodes. I have not heard that.
well, we'll have to look it up, huh?
Yeah, I always learn so much from the chat. And of course, it's from Mr. Smart Guy, Jarvis.
So, I'm right now, we'll have a little fun here, Sean. I'm trying to set up real quick. I'm going to take this apart and try to put it in AC. But
Okay.
first, I need to resonate it in DC just to make sure that I can switch it. You know what I mean?
Mm-hmm. Makes sense.
So I'm using my clip and my DC power source. So this is about as easy as it gets, guys, by the way. All I'm doing right here, you can go ahead and turn on the other camera.
Okay.
So all I'm doing right here is I'm taking this side, I'm going to connect it to my Tesla coil here, and the clip's going to go on there. We're going to be in DC power on this big Tesla coil right here. So I'm connecting to that one, and I'm going to find resonance real quick. It shouldn't take too long. I've been doing this for a while.
So your power supply goes to your ZVS board. Your ZVS board goes to coil 1. That's what you're showing right now.
That's right. So if I could put the screw in the right place, I would have it. Magnetic screwdriver. Wow. Okay. The right side always goes to the bottom. The left side goes to the clip. Start out on the third one. All right. All right, so let's go set up over here. Here we go. I grounded it as well. Let me turn it on to 10 volts. Here we go. Hold on. We're at 11.6. We're good. We turn it on. Our green light is on. Right. Oh, camera's flipping all over the place. All right. I could tell you right now that resonance field sucks.
Yeah.
That would just blow out in AC. No, that one sucks.
Yeah, not good at all.
No, I'm not getting anything. Okay, hold on. Maybe Nathan is not so smart right now. And maybe you should put the probe by it, huh?
Oh, I've done that 100 times.
Okay, now we got something. Not good. Still not good. Nope.
Thanks for the patent, Jarvis.
Man, we are getting a terrible resonance frequency.
Yeah. What's up?
It might be our grounding. Because we're in the general area.
Yeah.
Or it's just on the drop off.
It's always the tricky thing about getting that clip just perfect.
Hang on a second.
Feel free, guys, to share your comments. Feedback is always appreciated. While Nathan is getting his apparatus working.
How about that, Sean?
There you go.
That's what we're looking for, right?
Yep.
Wow. I hit it right on the head right there. Look at how far that is.
Wow.
We're definitely a little over 3.5 feet.
That is.
And we're at 11.6 volts.
And it's a ZVS. It's not even the Slayer. That's incredible.
Oh, yeah. We hit it. Okay. Hit it at 261. That's where it normally resonates. Okay. Well, let's not touch anything. Turn this off. Let me just verify. I'll turn it off and on one more time. All right, you can switch it over to the other camera, Sean.
Okay.
So now, oh, this is fun. I dread this one, but Sean loves doing it.
What's that one?
When you connect AC to your Tesla coil instead of DC,
yes,
sure does make for a fun day, huh?
With the backwards diodes.
I got it all in there. I didn't mess with it from last time. Make sure it's all off. Or else Nathan becomes a Christmas tree.
Stephen Drysdale says, what would happen with 6 inductors placed sideways and on top of them faced out, just above the Slayer like a flower top? I've never really thought about hooking up coils that way. I don't know what would happen. Are you talking about the coils being the secondary coil of the Tesla coil? Or are you talking about a top load? Sounds more like a top load.
Yeah.
So Anthony Williams says, idea would work using permanent magnets to the motor and only attracting one side. Can't tell if that's what he's doing.
No, I'm telling you, there's no magnetic field in there like you think it is. It's opposite. We know it from Mike's motor, too. He verifies it.
Right. So Right now, the experiments had been run from a DC power supply. So what Nathan is setting up now is an AC power supply. And because the ZBS requires DC only, he puts a diode on one side that filters out the negative part of the AC, and you only receive the positive. And so that positive pulse AC, or it's really DC now, is going to enter into the Tesla coil, and it's going to give a lot of different effects.
All right, give me a second. I'm going to clean up a little bit.
I would love to make glasses that could see magnetic fields. Yeah, I would love glasses to see any kind of field. Someone said, I bet we can get Sean to read some dirty words. Ha ha. No, no.
Sean, did we? Oh, well, I'm over here turning the dial and I don't even have it plugged in. Okay, sorry.
No worries. This is going to be interesting.
No, I got a hum.
Uh-oh.
Something moved.
Are your diodes facing toward the variac?
No. We're good on that. It's not that.
Yeah.
It's something moved. So I must have been on the edge of resonance. Hold on. Yeah, I was.
Oh, the clip.
That's what's so hard about switching back and forth.
It doesn't make the input voltage half. Well, maybe if it was average, it'd be half. I guess you make a point, John Curley. Stefan Dreizel says your setup is like a Wardenclyffe tower.
Yeah, it is. Okay, we took it way out of resonance. Man, I truly dislike this thing. Give me 1 second. It might be my ground again.
No worries. I can go through the comments. Let's see. I think they use polarization shift, Faraday magneto, optical effect to view the sun's magnetic fields. So I think Anthony's talking about seeing fields with your glasses. And Lionfire, who asked the question, said nice. Ulysses says Sage is filtering out of the frequencies. We should just place the word scalar with potential. Bulgarish Ian also suggested. Yeah, the use of terms seems like everybody has sort of a mix of terms for the same thing. I heard a term used just recently, non-Hertzian waves. And then I dug a little bit deeper and it was a longitudinal wave. And then I dug a little deeper and it was a scalar wave. And then I dug a little deeper and it was a Tesla wave. And I just thought to myself, oh dear, so many names for the same thing. So yeah, it's French science is tricky to learn. I've only been exposed to this for a little over a year. Not even a year, actually. So I have a lot to learn, guys, and you guys have been good teachers, so I appreciate it.
All right, this isn't going to go, Sean. I got to take time to set this up right.
Oh, man. How about your Slayer? Would that be easier to set up?
Well, hold on. We wanted to burn something up, right?
Yeah.
Yeah, well, I think I have a solution. This one I'll have to do when I have it set up the right way first.
Okay.
Let's just move this stuff to the side. All right. I don't like putting in that AC in there, Sean. There's got to be an easier way, and I think with that meter you said, it might be way easier.
Okay.
You remember what you're talking about? Oh, give me a second.
Okay.
HSR, HLR. Ringing any bells?
The LCR?
There you go. Whatever that meter was.
Have you used it yet?
No, I haven't. No, I was asking you, maybe you could explain it to people on how it works real quick while I'm setting this up.
Oh, you're going to pull it out and do some measurements? Is it
No.
LCR?
No. I was simply suggesting if I put it in AC voltage, it would be easier with the LCR meter to get it right.
Okay.
So, sorry.
No worries. So,
I'm just going to hook up my DC flyback, by the way.
There you go. Yes, Mr. Lania says Eskimos have 100 different words for snow. That's a good point.
Yeah, some people are sticklers on words too, so because everybody thinks they mean something different.
I try. I try to go with the right terms, but I like the fact that we all take each other more by our intentions, and instead of being all nitpicky about words. Working in the corporate world, you make a mistake with a word, and they look down on you. It was a tough 18 years. I had a good time though.
Okay. We are about ready. All right. We have a hot dog. I have power. All I got to do is set something up under this. I need a little box. I do not like putting this stuff down on the melamine when I use these flybacks. Not the circuit anyway, because they tend to energize the melamine with static electricity.
You could fry a MOSFET with static electricity.
Okay, so we got. Yeah, that one's still got a hot dog on it. We're going to put them close together in this first one. Or do you want to see it spark first?
Yeah, just see what kind of power is it before you start connecting wieners to it or something.
Well, I need a stable sitting place, so we'll make a spark gap wiener.
An angry wiener.
There we go. Let's see what we get. We have that off. Ooh, I could tell you it is on, but hold on. There's got to be a better way. Give me a second.
I love how the chat's listening, but having also their other conversations. Stephen Drysdale says, I'm sorry,
There we go, look. Okay, hold on. Give me 1 second. Let's go to the other camera.
Gotcha.
I think it was heating up the wiener.
Yeah.
But it wasn't like showing the energy.
Oh. The wiener was hot?
Oh, the wiener was hot, yes. Got a hot wiener. Yeah, hold on. not fair.
Oh, wow. You're arc welding on a wiener. That's some good sparks.
That's only 14 volts.
Oh, wow. Do you know the frequency?
So let's turn it off real quick.
Oh, it's DC because it's flyback. A pulsing.
Yep. So let's have some fun. Let's set up this orange. I don't know if it's going to do anything. I was hoping that Tesla coil would do it so I can rip one of these things in half.
I know. Someone in the comments says, do not try this at home. And that's a good point. This is something that you need to have experience in electricity before you try this. There's 100 different ways you can get shocked real bad. And Nathan makes it easy because he knows what to touch and what not to touch. So yeah, good point to bring out safety.
Let's see. It's definitely having an effect on stuff, but it's not. It doesn't want to spark over. It likes to heat it up.
Interesting.
You see that area right there?
Mm-hmm.
I can see around the anode or cathode, it's starting to bubble a little bit. Oh, this camera.
It's boiling the liquid.
Yeah, but it's not sparking over.
Interesting.
Kind of tells you the difference between hot voltage and cold. We were lighting everything up. Now we suck. Okay, well.
Yeah.
Let's
I've never seen
he's got a light bulb. I'll poke it in there. I got nothing.
Yeah. What's your frequency of the pulse DC?
$93 hertz. It may not be a.
That's low.
Yeah.
93 hertz?
Well,
we'd be hearing it.
Hold on. Just put it closer. See if I made a mistake.
No.
It's the crappiest wave ever, Sean.
Yeah, that's the wave you want, though. The positive pulses.
A pimple wave.
The diode is cutting off the negative pulses.
Well, this isn't entertaining at all. This sucks.
It's learning. It's good learning.
Oh, no, this sucks. Okay, let's see what the grapes do. Come on, grapes, save me. This is painful to watch. I love voltage, man, but this is painful. So take a look. It was burrowing holes in there, and one side was just lighting it up.
Yeah. The other hole's boiling, right?
Yeah. It's definitely contacting the energy, but we're not getting what we wanted out of it.
Mm-hmm.
That really sucked. I hate it when you do all this work and you get no fun. Like
well, I mean, you've done a lot of really cool things, and we've been on here for an hour and 40 minutes of fun.
All right, hold on. They're close.
Oh, check it out.
That looks exactly like it did the other time.
Right. Mm-hmm. That's interesting.
Okay. Let's go up to 18 volts. Nope, they got to be touching somewhere. Okay, hold on. Oh, I know I'm going to get shocked.
Oh, yeah. That's shocking energy right there. That'll bite you. Look at that. Nice. I have to try some grapes with my Tesla coils. They're so peculiar. That's
cool. It's smoking. We got some smoke. Hold on. Burn it some more. It's dancing.
I've never smelled a burnt grape before.
Oh, there's a little bit of smoke.
So someone's asking, have you tried the secondary of the Tesla coil instead of a flyback? That's from Jar Jar.
Have I tried the secondary of the Tesla coil instead of a flyback?
Yeah.
I
I'm not sure.
connected this energy to the flyback and ran the flyback.
Yeah, I'm not sure I understand the question.
Man, this sucks. All right, well, let me hook up my other Tesla coil. Man, I wanted to have something just tear in half. Hoping for the holiday.
Yeah, it's something to go out with a bang. I mean, if you're getting 8-inch sparks off that thing, you could do some hurt on those on your fruit.
I got it to 13-inch sparks on it, Sean.
Oh, you broke the 1,000,000 volts then. I think 1,000,000 volts is 10 inches.
Well, we got 13 inches on it.
That's amazing.
So I wish I could show it today. I think, I don't know what's going on. So frustrating. I'll have to set it up the right way and just do it on my channel later.
Sounds good.
So.
Oh, so Mr. Landis is saying a secondary coil instead of a wire down the middle.
So it's funny he says that. Okay. So how do I want to say this?
I know the answer too.
Hold on. I drew it up. Let me see if I have the picture. Give me a second.
Yeah. Instead of the center rod, why aren't you using the breakout of the coil 2?
Because it directly affects coil 2 and it'll pull more power.
Yeah.
It ruins the entire effect.
It doesn't. You can't push anything out of that secondary coil wire. You can't put a diode on it. You can't push it. It's a very finicky. If you connect things to it, and it will just stop working or heat it up or damage itself. But that awesome 13-inch sparks, that's what you get. You can't connect anything to them. That's my experience.
Yeah, I had the same thing. It doesn't work like this. So that's why everybody, when they go to try this and they don't do it the way I told them to, that they're gonna just fail.
Yeah, it doesn't. That's the fascination that it works with the rod down the center, because then you're able to extract some serious power out of it, but it doesn't disrupt the balance of the primary and secondary coils.
Okay, take a look. So this is the rod I was going to put in the center to do hot voltage. Okay, this is going to be hot, not cold at all. So we just use a PVC pipe, and then I'll wind the winding. Okay, one end goes to the left side all the way down. They're connected to each other. The right side goes over to the field. So each one of them has a level on the field, right? We can see the left side coming over here connected to the right. Then all of this left side individually connects there. So I wanted to see if I can multiply it without putting any diodes in it, right? Can I get more energy out by dividing up the thing? So that's what I thought he was talking about just there.
Okay.
So I don't know if that's going to work or not, but that's first shot. That is not the winding of the wire in order to create the diode. That is simply, can I create hot voltage and run it over unity like Don Smith? That's all that is.
So is this something you're working on, or?
That's something that's on the bench right now. So, yes.
Mhm. Wow.
Because I wanted to get over Unity just in the hot side of the coil, because the cold side is just different. It's meant for a different purpose, not meant for what everybody wants it to. It's not hot energy circuit. We don't want to run motors off of it. We simply want to run it the way it is because there's so much power.
Right.
I'm not really that interested in getting the hot power besides doing just a straight up hot power experiment,
Mm-hmm.
because the joy of this is that when I
Yeah.
multiply it out, I now have a gravity well. See, that's the difference. I know the scalar field is going to create a gravity well. I know by multiplying I get a gravity well.
Mm-hmm.
So that's what I'm going to do.
Sounds good.
Okay. Oh, wrong one. That one. Okay. Now, we are connected, Sean, and I'll just do a couple more experiments because I know it's been a long day so far.
Yeah.
Just want to leave on a good note because I don't like, bad tests.
Okay.
So what do you want to do as the final one? Sean,
Yes.
what do you want to do as the final test?
So can we throw some big sparks? And then put the hot dog in the middle of them?
Yeah, we couldn't get the big sparks. Remember, we didn't hook in the AC side. It wouldn't work.
Oh, that's right. That's right.
Or else
Can
I
you
would have done it.
Can you get a continuous with that thin wire? You know what I'm talking about with the DC input? Or is the ZVS just not working?
Yeah, it's not going to give us what we want. It's not going to be fun today. I rehooked my Tesla coil back up.
All
So
right.
we have cold energy and a bad resonance. Give me a second. I'll fix that. Sometimes this takes a minute.
Okay.
So what do you want? Burrito power?
Yeah, let's do burrito power. I'm putting my email address in the chat here for people are requesting to connect with me.
Yeah, go for it.
Something squealing.
Yeah, well, we're almost there. Take me just a second.
I only check my email about once a week, so if you want to connect with me, it's faster. You can use Facebook Messenger. I'm pretty easy to get a hold of there. I probably hit that every other day. But yeah, if you want to share your stuff and your research, would be great. I'm currently working on research with Nathan. I'm working with research with Brent Jarvis. And so, yeah, I'm open. Oh, Charlie C. I forgot, working with Charlie C.
Nice. What are you and Charlie up to these days?
He's trying to get his sphere Tesla coil working. So he
Nice.
just got it wound. He's now going to put it in some epoxy. During the holidays, though, he said he's not going to think about a Tesla coil for the holidays.
I don't blame him.
Jarvis just gave $5, my man.
Right on, Jarvis. Thank you. I appreciate it.
And he's making a request.
What's that?
Oil and salt mixture, please. oil alone first, then add salt, please. Stir, please.
Does he want motor oil? Is that what he's asking for, or is it a different kind?
The mineral oil.
And the salt? Just standard kitchen
Just
salt?
salt. Mm-hmm.
All right, hold on. You want to see if we unhook this? I'll go in the house and grab it.
The mineral oil that you had? Oh, the salt.
I'm going to go grab the salt, yeah.
Oh, he said vegetable oil. Sorry.
Vegetable. Okay. In just a minute. I'll be right back. Oh, go the wrong way.
So, Ulysses, you're asking the question about some kind of spray or mist which illuminates in the field. What field are you referring to? And the reason why it's so difficult to see fields is because by definition they're invisible and they go through things. So so when things go through, let's say, a wall, it's really tough to see it. So to get creative and create what is called what is called a cloud chamber. You can DIY or buy a cloud chamber, and a cloud chamber evaporates alcohol into a mist, and then if you want to run particles through it, like let's say electrons, it'll interact with the mist of the alcohol, and you'll be able to see how fields are working, at least the negative charged electrons. So that's one way to see these fields. Electromagnetic fields, it's a little trickier. I've seen guys just use fillings, or they'll use that strange magnetic field paper, where you can sort of see how the fields are. Those are a couple ways to see the invisible. I've been trying to solve that problem, and so it's no coincidence that it's a place of interest.
Okay, so we are set up. I have salt right here. I'm going to give them the best chance, so I want to put them somewhat distance, not much. Okay. Oh, this stuff is nasty. We do have the vegetable oil. Stuff gets all over you, and it just likes to slide. It's like my whole table wants to slide now. All right.
It'll take a week for it to go away, too.
Yeah. Okay, so we got 10 volts on our Tesla coil right now. Wires connected to down the center and everything. You want the salt in right away?
No salt and then salt.
No salt and then salt. Okay, so 12 volts, no salt, no light.
Yeah, no energy. Now you're adding salt. This is cool.
I sprinkled in a little bit between it.
Yeah, good idea, Jarvis. This is cool.
A little more. Hold on. So go to the other camera real quick.
Sure.
There's a salt line.
Interesting. Is the salt moving toward the electrodes?
No. You got plenty of salt in there.
Yeah.
I'm up to 21 volts. Oh, I got some light in there, Sean. Look right there.
The plain oil, we got no light. So salt is making oil conductive. And you can't hear it, but this is what it sounds like. That's the exact sound it's making.
So, Jarvis, you are 100% right. That's awesome. So, I don't know. We can look at the salt. I don't know if it's the salt itself that's just making a bridge, though.
I'm wondering if you stirred it and then just, you know what I mean, instead of pouring the salt over the electrodes, but kind of stirred it in evenly, then put the electrodes in. Because it might just laid a whole big stream of salt on them.
That salt, by the way, looks like it's separating. So here we go.
There we go. Let's do it.
It's on.
Is it on?
There we go. Now it's on.
So
okay, we're on.
Yeah, no light. Oh,
hold on. There was a little.
When you touch it, though.
We're at 23 volts now. And I got a little right there when I touch it.
And it goes when you touch it.
It's got to be the salt conducting. So the only conductor in there, by the way, is the salt.
That's amazing, though. You know, do you have a multimeter?
Yeah.
I wonder if you just made a resistor. Put the multimeter one side of the container and the other probe on the other side. I wonder how many ohms of resistance. And this would be super cool if it was a resistor because you could make it adjustable. Like
so hold on. Is it, you want it on ohms, right?
Yes, on ohms. Oh, this is so cool.
Okay. So here, you tell me. See, I wish it just had an ohm setting. It has this number next to it with a symbol.
Yeah, so put it on the highest setting, which is, what is it, 2 mega ohms?
2K?
2K. 2K sounds fine.
Okay, now where do you want the probes?
So just put one at one side of the container and one at the other, touching the oil with the salt.
Okay. You turn it on.
So first, no, leave it off. Turn it off.
Okay.
Take your probes, touch them together so that way your meter reads 0. Awesome. Now you're ready to put one probe on one end of the container and one on the other.
Okay, I got to turn it on. I only have 2 hands.
No, you don't need to turn it on. You're measuring the resistance of the oil.
Okay, so
oil. Exactly.
I got OL.
Yeah, so do you have higher than 2K?
Nope. I have a buzzer.
Yeah,
and that's nothing.
So it's such a high resistance, you can't measure it on your meter. That's very fascinating. That was worth it. Thank you for doing that. I'm sorry everything's oily.
Yeah, everything. I'm going to be washing stuff for days.
I blame Jarvis, though.
I might have to get some new cheap little wires now.
Yeah, the latex gloves, I think. The cheapies.
All right, so hold on. Let me unhook these nasty wires. Get rid of this stuff, man. Oh, this maybe just hit the trash can. I don't know. This is bad.
Poor guy.
Okay.
We're learning a lot, though.
Well, yeah. Let's just learn it. I put the rod all the way through the wiener this time.
Yeah, I'm getting comments. Yeah, it might be in the mega ohms. Yeah, I agree. I have a Megger. That might work. I can read. I forget how many gig. 4 gig ohms, I think, with my Megger. But a regular meter is not going to go through it.
Goes right through that hot dog. Nothing happened to the hot dog though.
Is it
Make
getting
sound?
warm?
Ooh, that hot dog is hot.
Yep, that's what I thought. It's a plasma wiener.
Yeah.
I wonder how long it would take to cook it.
I don't know. You have to first resonate your wiener, I guess.
I was thinking you were ionizing your hot dog.
It might be. Okay, hold on. Give me 1 second. Man, I got like pie everywhere. Everything is.
Oh no.
I figured
I have
that's
not
all right.
measured a chair, a plastic chair. I have not measured it.
So I'm looking for that knife I had earlier.
So, someone
There it is.
asked, did you see any fields in the oil?
No.
Okay.
Oh, here we go. Doing an orange with a butter knife.
Oh yeah, because they're asking if you could do it cut open. Mm-hmm.
Okay. Okay, that one's in there. Take that out of the wiener.
White light? I don't get it. There's a conversation going on in the chat. I'm not catching
Yeah,
it.
they're probably saying I'm going to the white light after this.
Oh, I see.
Okay. How's that look? So we have it coming in. I looped it with a wire right there.
That's funny.
Out the other side. All right, let's see if it does anything.
See what it does. Look
Well,
at
it lights
that.
it up. Okay,
Nice.
let's look at the orange though. Oh, this camera, I swear. Do you see any bubbles? I see juice.
Yeah, I see bubbles. I hear a high-pitched squeal. And the high-pitched squeal gurgles when you touch them.
That it's getting hot.
Oh, really?
Yeah, there's some big RF field in this stuff with that acid.
Wow.
That's crazy.
It is crazy. It's a great finale to a great night.
Yeah, hopefully we all learned something. So
I learned a lot, to be honest. I really did. The salt experiment with the oil was really telling.
yeah.
It'd be fun to play with oil because I'm always looking for high resistances that I can control and not have to worry about a potentiometer or buying one. And it looks like oil with salt might have that ability. And so I learned that. I learned Nathan can do anything with electricity and food.
Burrito power. That burrito's got massive power to it.
Right.
I think what it's doing, Sean, is it's flipping my field. It's going from cold to hot energy, and as soon as it did, it still has some effects of the cold energy. It's like it's going in between the hot and cold like this.
Yeah.
and it's flipping. So, or it's
Yeah.
just putting off a very high RF, which gives me the heat. But I bet you that thing is cold. So hold on.
Oh, you're getting the thermometer out?
Yep.
Oh, Happy New Year. See you later. Not sure. Happy New Year, Jar Jar.
So we're at 65 degrees on the orange.
Okay.
That means we're getting high RF.
Is it cold in the garage?
Well, the table is 69 degrees, 70 degrees.
Okay.
So it's a little lower than that. Huh. All right. Well, at least I know what's going on. It's not hitting the hot side. It's just making it hit a high RF. So, man, that's cool. Well, Sean, I want to thank you for hanging out with me today, man, and doing this.
I had a blast. I thank you for inviting me. I really appreciate it. I hope you guys in the chat had a good time. I want to do more of these with you, Nathan. I like being your wingman.
I like it when you're there because I have trouble going back and forth to the chat, and you do such a good job with it. It works out great.
I appreciate it. I really do. Lots of good comments, Nathan, about how good you did tonight. So all around, great job.
Right on. So hopefully I made it fun for everybody. So, all right, guys, we'll probably do more of these in the next coming year, and we'll see if we can't get our hot voltage working. As soon as it does, man, I'll schedule another one, and we'll do it with the AC only. And I was kind of hoping for it tonight, and I should have just set it up first because it's finicky. But
yeah. And you said tomorrow's Wednesday's live stream is still on the docket.
That's correct. So we do the workshop tomorrow, and either you can hang out or present, whichever you prefer to do. But we're kind of going to go over some pictures and stuff. I got a lot of stuff to line things up for pictures, and people seem to like that when we do that. We did ancient Egyptian pictures and how they tie into current stuff and what we're building. So I want to do some more of that as well. And then I know Ben probably has some updates on his stuff. So, but if you got something to present, Sean, by all means, the floor is always yours first.
I appreciate that. I don't have a whole lot, but I've been playing around with I built a bipolar Tesla coil, and and then I'll tell you where my status. I'll give you a status update of the electrodes. A lot of good learning getting to the electrodes, and I can't wait to share it with you guys.
Right on. Yeah, I want to definitely hear about that.
Appreciate that. Hey, we love you guys in the chat. You're awesome. Happy New Year. And thank you, Nathan, for having me.
Yeah, not a problem. All right, guys. That's it. Have a great night, and we'll see you next time when we do some more frying. Hopefully more frying next time than just cold energy. All right, have a great night, guys. Thank you guys in the chat.
Bye.